This morning, Google released their new version of their Generative AI Python SDK. It's version 1.0, so it's nice and official. They also released a guide on how to upgrade your old code if you're using the previous version of their SDK. I've already upgraded my code for this tutorial, so I'm going to show you the latest and greatest on how to use this SDK specifically for Gemini 2.0 and specifically the Gemini 2.0 Flash model with the multimodal and structured extraction features. So what do people like about this Gemini 2.0 Flash? Well, first of all, the token limit. You see there's 1 million input token limits, which means you can send in huge amounts of text for it to analyze, unlike a lot of these other models out there that only handle 32K or 128K of input context. The other thing people like is that it's multimodal. So my wife is a speech therapist and she's doing, I'm helping her with some AI for speech pathology. So understanding people's voice, converting that to audio, giving feedback on that audio, and exploring that whole realm because it's very niche. And what's nice about this is I can send it someone's voice and audio directly without having to transcribe it, and it can give me a lot of information about that. It can process that audio. Not only can it process audio, it can process video, so you can send it YouTube videos, or you can send it in images, and it can understand and use its vision capabilities to look at the image and understand it. So not only does it have powerful capabilities, it's also very cheap. I mentioned sending it a bunch of audio and video data, and you'll notice that I'm spending cents here, not dollars, not hundreds of dollars. I'm spending like 50 cents, 21 cents. So the bills are very low, even if you use this thing quite a bit, which means it opens up for like an independent developer like me. It opens up a lot of use cases for being able to actually provide software to tons of different users that use the software. So you're not going to spend thousands or hundreds of thousands of dollars on some cloud bill. You can do this relatively cheaply. So on this channel, I focus on financial projects and use cases, and mention I'm going to focus on the structured output features and the multimodal functions of the Gemini API. So I'm going to walk you through a few examples I had in mind. The first thing I'm going to look at is the Citrini Research Report. This is a PDF that's published by some guy on Twitter named Citrini. I think he's the top financial Substacker. And so each year he posts 25 trade themes for the year, and this one's in a PDF for this year. And so I'm not going to share his 2025 outlook because this guy's running a business. I don't want to interfere with them, but I will. His 2024 post, so predictions for 2024, is public. So this was posted in 2023, and so now he'll share that now that the year is over. And so you'll see, he has different themes and then trade ideas for each of those themes. And so you'll see, last year, Marvel, Broadcom. I also like this report because he posts both long and short ideas. So last year he had one on long Cloudflare and CrowdStrike and short Okta, for instance. And so this was under the cybersecurity theme. So one cool thing about Gemini 2.0 Flash is it can take this entire 126-page PDF that I download from DocSend here, and I can just feed this in directly, and it can extract the exact themes that are in this document and the exact stock symbols that are mentioned in this document and the exact companies. And so imagine you're ingesting thousands and thousands of PDF on the daily. My email box has tons of newsletters and things like that. Imagine you're sending these through some type of pipeline, and you want to extract all the stocks in here, and then you might want to send them up to a follow-up step. And if you were working with these models in 2023, you probably took these PDFs, you used some library like PDF Miner or PyPDF, and then you chunk this up into little pieces, and then you got little text chunks, and then you tried to assemble them all together. With Gemini, I can just upload this entire PDF and then just start asking it questions, extract some information from the document, and send it off to another step in my pipeline. A second example we'll go through is extracting audio. For instance, the Lex Fridman podcast. This most recent podcast he did a few days ago is with Dylan Patel of semi-analysis. Now, I don't know about you, this is 5 hours long. Do you want to hear Lex Fridman talk for 5 hours and sit through that? No, you'll probably fall asleep. But this is with Dylan Patel. He's the founder of Semi-Analysis. He has tons of insights about the future of semiconductors and how this whole data center build out and semiconductor space is going to evolve through the year like 2030. And so he has very detailed analysis in his Substack, and also he shares some of this in this video. Now, what you could do, even though this is a 5 hour long video, you could try to send this to Gemini or send the downloaded audio. So you can go to the episode here, download the MP3 file, send that audio in, and have it extract key information you're interested in extracting. And there's actually people out there that are just processing every single podcast that comes in and extracting all the latest information. And why might you want to get information on a topic like this from a podcast? Well, a lot of times there's guests that are actually experts in the fields, actually founders of technology companies and people that, started in, you'll have Jensen who started NVIDIA or someone like that presenting. And, if you get your information from CNBC or some Wall Street reports, these are usually just a bunch of old guys who've never actually, they've never founded an actual company. They've never actually developed anything. They don't even have an NVIDIA GPU at home, but they act like they know about the topic, right? And so a lot of times you can get information here that you can't get anywhere else because these are people that have genuine insight into how things are going to actually play out. For instance, if you were watching the OpenAI Dev Day on October 1st of last year, you'll notice they did a lot of demos of real-time audio and integrating Twilio as a tool. And so you could speculate, oh, maybe Twilio would be a beneficiary of agentic AI and tool calling, incorporating their tools for phone calls for customer support and SMS text messages. And you can see if you go to TradingView here, one thing you can do is paste a tweet. And you'll see there was a great entry point into Twilio, you see right here, where this was announced. And you can see it was $60 a share. And this is a trade I actually took. And you can see it's more than doubled now. It went from 60 to 145 over the last 5 months. Not saying I'm anything special or that I'm giving stock picks here. I'm just saying if you pay attention to what's going on, a lot of times you can find information buried in podcasts and videos. The other thing I'm going to look at is there's all these millions of people making predictions on YouTube. And so Gemini can look at video and, a lot of people that make these predictions are super bad at it, right? And so what you could do, one project I always thought would be kind of cool is to process all the people that make predictions on YouTube about 10 stocks ready to explode on stuff. If you fed those all into Gemini, you could extract the symbols they mentioned and a timestamp of when the video was published, and then you could turn around and use tool calling to call a function for each of those stocks and be like, oh, how have stocks performed since they were recommending it? And so I think that'd be a pretty cool project to put together. All right, so on this channel, we always write Python code and we create actual projects. We don't just use AI tools in the browser. And so on GitHub, I have the code shared, and I just committed this like an hour ago, hot off the press right after this SDK was released. So you can clone this code and follow along with me because I'm about to walk you through it. And if you have a chance, if you're on GitHub, go ahead and follow me. Part-Time Larry. It's on my Hacking the Markets repository. You see, I'm going for vanity metrics now. I know someone put together a GitHub users ranking and I'm number 596. So I want to climb up this chart right here. So let's go ahead and get started with the code. So on the README page for the repository, I put a few instructions. You should already know this stuff if you're following along with me. I've gone over it a million times, but I'm using in my editor here. You can use Visual Studio Code. I'm using Cursor lately because AI coding is kind of taking over and it's making me lazier. So I'm using Cursor here, which is just a fork of VS Code. Suggest you check out Cursor if you haven't already. So you just create a virtual environment as we always do. And so I'm gonna do Python 3-m like that. And your environment may be slightly different. And so I create a virtual environment, I activate it, and then I'm gonna install the requirements. So I'm gonna do pip install -r requirements.txt. What's in the requirements.txt after we clone this? If you look in requirements, you see I'm using the new Google GenAI Python package. I'm using python.env to load my environment variables from this .env file. I'm using YTDLP, which is the best and most up-to-date YouTube downloader out there. And then Pillow, which is the Python imaging library, because we're going to look at some images with Gemini. The next thing we need is a Google API key, and you need to place it in a .env file. And so the environment variable is called Google API Key. And then the environment variable is called Google_API Key, just like that. And you put yours right there. Mine is in my .env file right there, and I'm not going to show it to you. Now, how do you get a Google API key if you've never done this before? Well, they made it really easy now. It used to be more difficult, but thanks to feedback from developers, they're making this simpler and simpler. And so you just go to aistudio.google.com and you do get API key. On this screen, you need to associate your API key with one of your Google Cloud projects. So it'll have a drop down here and you select your Google Cloud project. And I do create API key and it generates it right there. Now, how do you get a Google Cloud account? I promise it's not that hard. A lot of people complain about this. You just go to Google Cloud, you click New Project, and you associate your project with your billing information. That way, it can bill you for whatever tokens you use. All right, so now that I'm all set up, I'm going to walk you through each of the use cases I talked about and some I didn't talk about. So the first thing I'm going to walk you through is this extract image.py that's in the repository. And this is going to be a simple example to make sure that we've set up our API correctly, that our actual Gemini client works, and that we can actually use some multimodal functionality. So we're going to analyze an image. The image we're going to analyze here is called IPO Pulse. If you watched my deep research video, you'll know that I was looking at private SaaS companies and trying to determine and make predictions on when the IPO window might open and these companies might IPO. Now, on Twitter, I saw one day there was this IPO activity, this IPO Pulse chart that was posted. I think it was from Goldman Sachs. And what this does is indicate when there was downturns in activity, so where there was lulls in IPO activity, and when IPO activity, was booming. So in 2021, you can see there was a huge wave of SPACs, IPOs, and that sort of thing. Can Gemini look at this image and understand it and describe how the IPO market looks? So if you've ever chatted with any of these models about financial forecasting and IPOs and things like that, then you'll know it says, well, it depends on what the state of the IPO market and things like that. But if you feed it an image, right, it can fill in additional context. So if you ever write Python code to do this, then here's what you need to do. You need to import the GenAI package from Google. You need to import the Python imaging library here so that we can read the image. And then you need to load the environment variables so that we can set up the API key. The API key is already in our .env file. And when you call this load.env, it'll load the Google API key into our environment. Next, you need to instantiate the GenAI client, just like that. And you need to specify a model. Now, there's a big list of models. There's hundreds of these now, which is getting kind of confusing at this point because there's so many different dated versions, but this stuff moves fast. I'm going to focus on Gemini 2.0 Flash since it's pretty new, pretty stable. So then what I need to do is call this generate content function. And this is a workhorse. It does everything for you. So this will take care of using my client, and it just calls the Gemini API. And I just need to give it the model I'm using, which is set up here, the 2.0 Flash model, and ask it a question or contents, provide it some contents to analyze. And so this might be text, like a question. It might be a prompt, but it also can be audio. It can include images and other things. It's not just a text prompt. And so I'm going to start off, the simplest example is a text prompt. And the contents are, what is the stock symbol for Apple? Super easy. And then I can print the response text just like that. And if I run that, you should see it knows that information. Stock symbol for Apple is Apple. Very, very simple, right? So now I'm going to comment that one out, and let's see, how do you make it understand an image? So to do that, use the Python imaging library to load the IPO Pulse image right there. So I load that image, I instantiate the client again, and then I call generate content. So I pass it the model, but in this case, instead of just a prompt, I do a list here. And so the first item in this list, I have what is this image? And the second item in this list, I have the image itself. So this image that I just loaded, and I do response.text. Okay, and then let's see if it's able to actually understand that image, right? It says the image is showing a chart, is a chart showing the NASDAQ Stockholm IPO Pulse and IPO activity from 2015 to 2025, includes a line graph, a bar graph for IPO activity, and shaded areas indicating downturns in IPO activity. There's also a vertical dashed line marking a forecast point. And so I'm going to make this prompt a little bit better. I'm going to say, according to this chart, when did the IPO market peak? When did it bottom out? And what does it look like for 2025? Okay. And so if I run this, let's see if it changes its analysis, if it's able to dive a little bit deeper. And so it says, based on the chart, the IPO market as measured appears to have peaked around 2022. The market hit its lowest point around 2024, and the forecast for 2025 shows a recovery with the IPO increasing from 2024. And if you look at the image yourself, you'll see that the IPO market, there's tons of IPOs and SPACs and such happening in 2021. And then there was this peak in late 2021, I would suppose, or early 2022. You see it fell off a cliff, 2022. Sucked for everybody. And then you see this gradual recovery. And then you see this forecast that starts around 2025. And so you see, even though these years are not labeled very precisely, it's able to roughly determine where we are in this cycle. All right, so you can see with the Gemini API how we're able to accomplish quite a bit with very few lines of code. However, that was a pretty simple example. Let's make it a bit more complicated by adding the structured output functionality. And so let's revisit our equity trades theme report here from Citrini. And you see how he has all these different themes and then a bunch of symbols below them that match that theme. And so this is his 2024 report. So what I'm going to do is try to use structured extraction to just extract the names of the themes and also the symbols that are associated with each of these themes. Now, if you tried to do this with just regular string parsing, it would be very complicated. You'd be trying to do regular expressions and look at the size of the headings and all that. But what if you just pass the entire PDF over to Gemini, right? You don't even have to process the PDF and extract the text. You just send the PDF file. So I have extract newsletter.pdf that's in the repository. So if you look at the code, you see we do the same thing. We import GenAI, we set up the client, and we load the environment variables. But you see I have these bits here that are loading from Pedantic and these typing classes here. And this is so we can extract particular structured pieces of information from the document. And let me show you how you set those up. So there's a variety of ways to set up this structured output. Some people pass an example of the JSON schema they're using, but I like to use Pedantic here, which lets you get very explicit about how you want the data returned to you. For example, themes here. So I say I want a list of objects. So I want a list of themes in this document. So I pass 126 pages and I say, just give me the names of the themes, right? And so to do that, I need to just establish this is what a theme looks like. A theme just has a name, and that name is a string. If I want to extract the companies, I say I want a list of companies. Each company, I want the following attributes. I want a name, which is a string. I want whether it's a public company or not, which is a Boolean. I want the symbol, which is a string. It's optional because it might not be a public company. And whether he recommended to go long or short. So a long idea is a Boolean true. And if it's a short idea, I have a Boolean false. Okay. And so what I can do is pass Gemini that structure and say, give me a list of JSON objects that match this structure, and then I can loop through them and do other things with this structured information. So how do I get that PDF file to Google to actually analyze? All I need to do is call client.files.upload, and I give it the path to my PDF. And so I have a files directory here with this Citrini Trades PDF right here. I pass it the file as a parameter to upload, and that gives me a reference to that file in the cloud. And then what I do, I just do a prompt just like I did last time, and then in the second piece, I pass it the actual file itself. So here's my extract themes prompt. I said, attach is a list of thematic trade ideas for 2025. Analyze the text and extract all of the theme names discussed. And I'm actually doing 2024 here, so let me do that. So once I have the prompt and the file, I just pass that list as contents. And so there's two different functions we'll talk about this time. First, we can generate the content like we did last time. But before I do that, I might want to count the number of tokens I deal with. So if I'm sending in a 5-hour podcast, that's a lot of information. That could be hundreds of thousands of tokens, or maybe it's even millions of tokens. So you want to know how many tokens you're using, not only for billing purposes, but to determine whether it even fits in the million context, million token context window. So what I'm going to do is count the number of tokens in the prompt and the file here, and I'm going to print that out. And you just call the models.countTokens function right here, very similar to generate content. The second thing I'm going to do is actually use generate content to extract the structured content from the document. Okay, so I'm going to count the tokens, then I'm going to call generate content. You pass it the model, you pass it the file and the extract themes prompt, and then you pass this configuration here in order to extract a list of themes. I told it what a theme looks like. So I have a theme, it's just the name of a theme. And then I say, I want a list of them. So I want my response to look a certain way so it's predictable. I can loop through it and iterate it over it like a data structure, rather than just a string of text and markdown like most language models report out of the box. And so since I have structured JSON, I can loop through each of these themes one by one, and I might want to call another function or call Gemini again. And so in this case, I'm looping through all the themes, and then I'm giving it the file, and I'm saying, extract all the companies mentioned for this particular theme, and I can dynamically build a prompt with the theme name I'm interested in, right? And then I call generate content again with my extract companies prompt, and I say, I want a list of companies. And so here I give it my company structure, with name, public, symbol, and long, and I just call this same document over and over again. You might want to look into prompt caching if you're using the same document over and over again to save on costs. And optimizing costs and prompt caching and things like that, and how audio and video tokens work is probably the subject of another video. There's great documentation for that. In this case, I'm just going to use the same document, and I'm going to extract each of the companies, and I'm going to list all the companies. And so I'm going to run this in order. So let me run this, and it's called extractnewsletter.pdf. You're going to see it's going to first look at the PDF and try to determine what are the themes in the PDF. I'm going to print out the raw response. I think this will take a few seconds because it's uploading the file. All right, the first thing we did was print the number of tokens. You see that 60,000 tokens right there, which is a pretty good amount of context right there. Let's see if it can use that effectively and parse this PDF all in one shot without us extracting the text. Here you go. It gives us the list of themes. You notice this doesn't look like a chatbot answer. It looks like a Python data structure. So I have the name water, geriatrics and elder care, the GLP-1 developments trade, the AI developments trade, and so forth. You'll see one of the themes discussed in this document comes through. It sends the prompt, blue-collar jobs and vocational training. I can't remember if that was an AI theme, like more people are going to try to do blue-collar jobs because their white-collar jobs are being replaced. You'd have to read it, or you can extract a short summary of the reason. The second theme was geriatrics and elder care, so he looks at these different senior living facilities was one example. And you see how I'm getting, whether they're publicly traded or not, what the symbol is, what the name of the company is, and whether it's a long or short idea. And then it's an actual like Python Boolean right there. Emerging market infrastructure spending, GLP-1 developments. He looked at Novo Nordisk, Eli Lilly, and so forth. When I get to cybersecurity frameworks, I mentioned there was a long Cloudflare and CrowdStrike and short Okta trade. You see long is true for both of those, and long is false for Okta. And so that long short was correctly parsed. And under artificial intelligence, remember this was written in 2023. So 2024, this theme continued. He talked about NVIDIA, Arista Networks, Broadcom, Marvel, Cisco, etc. And if you followed all these, there's some good ideas in here. There's probably a few misses. All right, so now to really stress test this thing, what if you send in 5 hours of audio into this thing and try to extract little pieces of information from a 5-hour clip of audio? And so the example here I used was Dylan Patel from Semi-Analysis, who was on the Lex Fridman podcast. If you click on episode here, you can either download the YouTube video and extract the MP3 there, or you can download the MP3 file right here. You can even automate this if you do the RSS feed, and each time a new episode comes in the RSS feed, you can transcribe this MP3 file and send it in and extract this information. And so what did I extract from this podcast? Some people like to extract a list of products mentioned or companies mentioned, but in this case, I wanted to extract these big, bold predictions about the future of AI. And so here I made a class called prediction, and I had one attribute is just called the prediction itself, like a sentence of what is this guy predicting? And then secondly, a time frame. Is this something going to happen in the next year, in the next 10 years, by the end of our lifetime, and so forth, right? And so I have a prompt here. I've attached audio of a podcast. Give me a list of predictions made by the interviewee and the time frame of the prediction. You see at the top, this is the exact same imports as the last one that I did for a PDF, but I send it in the MP3 file that I downloaded, and I put it in my files directory. I upload the podcast file. So the main difference here is the PDF, right after it finishes uploading, it's already available. In this case, it needs to upload the file. And since it's a 5-hour podcast, it's not instantly going to be able to analyze that. There's a little processing step here. And so what I do is upload this, and I say, I have a loop that says, while the state is processing, then display processing video, wait for 5 seconds, and we're going to display when it's ready. Once it's ready, we can get a reference to that podcast file. So if I run this, you'll see it's going to upload this MP3 file that I downloaded. Once it's uploaded, I print the name of the file right here so that I can reference it by name in the future. I print out my token count. You see there's 590,000 tokens here, so this is going to really test this thing out. I have my prediction model here, so I say what a prediction looks like. I have my prompt. I printed my token count already, and then now it's trying to watch or listen to a 5-hour podcast and extract a list of predictions from it. And then I'm going to just dump those out on the screen, and let's see what it's able to do. Now, newsflash, what I found out is if I try to send 5 hours of audio all in one shot, in one file with about 600,000 audio tokens here, it can't just extract all of the predictions in that file. So even though this allows for a 1 million token context limit, I still found that chunking things up into pieces still makes it work much better, at least for structured output. You can test, it might do well on question answering, for instance, but structured output, it just doesn't do as good of a job unless you send in smaller bits of information. So you'll notice the answer is not good here. It said predictions, AGI will exist, 2026. Coming very soon. Work on your smile and your personality because, yeah, this thing is going to be great next year. It's already impressive with deep research and all of that and what I'm doing here. And then many more better AI models will come, including reasoning models, both American and Chinese company, unspecified. So this structured extraction does not work very well for 5 hours all at once. But I'm not going to leave you hanging there with some crappy answer. Since I'm such a nice guy, I wanted to include another script for splitting audio. So you'll see here, ffmpeg, popular little command line library, lets you take an MP3 and split it into segments. So you can say how many seconds are in each segment. And so what I did was split this up into 15-minute chunks and then create a new audio file here. And I included a little split audio shell script right here. And if you look at this, you can pass in an audio file and it'll split it up into 15-minute chunks. And I found that worked pretty well. And if I look at my split audio shell script here, I make sure that's executable. And then if I run split audio, right, you'll say usage, split audio, and the input file. And so I say split audio, and I'm going to give it the path to my file, which is Lex Fridman podcast. And when it runs that, look, it's going to split this up into a lot of MP3 files and put it in its own directory. And there you go. I have an MP3 file, and they're each 15 minutes long, all the way up until the end, which there's 6 minutes left over. And so once I've done that with my files, you see I have extract podcast split Python in here. And if I go to that, you see I have os.list directory, list all the files in that directory, alphabetical order, and then loop through all the files, and then process the split files. And if I do that and upload all of them, you'll see as I upload them, I'm going to extract the predictions from these little 28,000 audio token sequences. And look, I get 2 predictions out of the first chunk. So that's the better AI models. And then it says the DeepSeek moment will be remembered 5 years from now as a pivotal moment in tech history. After 2030, there will be a nuclear weapon moment when geopolitically AI will be a real threat. Prediction, the fastest I can imagine swarms of autonomous robots in the military context is 2030, which is why I said 2030 for super powerful AI. China will win long term because of these restrictions, export controls. Intel can bring leading edge semiconductor manufacturing back. Prediction, China will not hit its goal of 80% domestic production of semiconductors by 2025. Prediction, superhuman persuasion will happen before superhuman intelligence. Prediction, you can train a language model to maximize time spent on a chat app in some number of years. Prediction, in the future, AI algorithms will control people's minds more than other people. Prediction, AI bots will get good at pretending to be humans and interacting with humans on the internet. Data center consumption expected to reach 10% of total US consumption by 2028 through 2030. Interviewee predicts a future where creators can opt into programs for revenue sharing on AI-generated content using their style. The next Llama version by Meta is going to have 1 million token context linked. And there's dozens and dozens of them that got spit out here. I'm not going to go through all of them. And you'll just need to verify, maybe you actually have to watch this 5-hour thing. But I thought this did a pretty good job, just me looking at it. I just ran it there for the first time to see what happened. I thought it extracted tons of information, and it was very thought-provoking and might make you trigger some other ideas in your head without you having to spend all 5 hours of your day watching and paying attention to this entire podcast. And that's not all. One more thing. So one feature I want to show you that's part of the app, and then I'll show you a way to do it through the API. In Gemini Advanced, if you have access to this, GeminiGoogle.com, if you select the 2.0 Flash model, one thing you can do is extract information from YouTube videos directly. And so you can see how Google is integrating these models like deeply within their ecosystem. So they have this huge treasure trove of data on YouTube. So I can tell it to watch a YouTube video for me. I can say, can you watch this YouTube video and tell me what stocks the speaker mentions and whether they are bullish or bearish on these stocks and why, right? And then I can paste in, I'll take this video from 2022 when we're first talking about AI, before there was a ChatGPT API or anything, just using regular old GPT-3, and I can have it watch this video. You'll see it can actually pull this up and connect to YouTube. And then it says the speaker mentions one stock in the video. NVIDIA says they're bullish on NVIDIA, and they believe there's huge demand coming for GPUs and AI for machine learning purposes. And he bought the stock a month and a half ago and is optimistic about demand for GPUs. Now, is that accurate? Did I say that? And cloud GPUs, which I actually bought some NVIDIA about a couple months ago, a month and a half ago, and so I'm kind of optimistic on the demand for GPUs and their use in machine learning. And there you go. Clearly, this guy, Part-Time Larry, is great. 10xer there, right out in public, buried there in a Python programming video. And they say you can't pick stocks, but, you know, if you've ever read One Up on Wall Street, he says sometimes you can pay attention to what's going on out there. For me, I'm paying attention to what developers are doing out there. And when you pay attention to what the people are doing that are creating the future, sometimes you see what's going to happen before people read about it later in an earnings transcript at the end of the quarter. So this video is getting a bit long, and the YouTube extraction is a bit similar to how I did it with the podcast. So I left a couple of commands and a script here. So if you want to download a YouTube video, you can just use the ytdlp command that's included when you install that library in the requirements text. And so you can download a YouTube video, or you can download a YouTube video as an MP3 using this command line script. So I have the command for it, and you just pass it your YouTube URL. And I left a extract YouTube Python script right here. And all I did was upload a video that I downloaded directly. I processed that video, and then I gave it a company model right here. And I said, give me the names of the stocks mentioned in this video, bullish or bearish, and why. Give it the prompt. And once again, we call Google Gemini. It can watch the video for it. And I think it can even look at individual frames in that video and hear the audio in there. And so now we're living in a time where for less than the cost of your morning latte at Blue Bottle, you can do months of work using the Gemini Flash 2.0 model and do multimodal AI for possibly months and analyze all the data you want, knock yourself out, and if you find one of these great investments, who knows, maybe it'll pay for lattes for the rest of your life. So that's all I have here. Hope you liked the video. See you next time. Bye.